Okay, hello guys. We are from Group 6, Section 5. So let me introduce myself. My name is HAZIQ or ROSLAN, and my other group members are HAMRA and AIMAN, NAVINDREN, and KHUZAIRI. So for today's agenda, we will cover all of this topic, as you can see here. So I will do the introduction and explanation of the list of this project and its related to SDG program. While the rest of this topic will be covered by my other members. So for the list of this project, we have 5 lists, which are the type of the boundary, cutting of vegetable branches, identified type of agriculture, quality system, and control system. So for the first one, which is the type of the boundary, we found that most types of the boundary in Malaysia is in the range of 2 meter to 6 meter. So our operated machine will be working in this range of 2 meter to 6 meter. And then for the cutting of fresh branches, we have so many options that can be used to cut the fresh branches, such as chisel, sickle, machete, and others. So there will be so many variations that can be used to cut the fresh branches, and you can see that during our conceptual sketch later on. And then for the identified type or AIMAN group, we have so many technologies that can be used to detect the ripeness of the fresh branches, such as color sensors, thermal sensors, image recognition, and others. So why do we want to use these technologies? Because we want to avoid human error and to get the accurate result of the ripeness of the fresh branches. And then for the quality system, we need this quality system because when we cut the fresh branches, we don't want the fruit to fall immediately to the ground. So what we do is that when we cut the fresh branches, the fruit will be fall directly into the quality system, so that we can protect its quality and also the texture of the fresh branches. And for the control system, we need this control system because we want to avoid manually man operation. So that by using this, we only require the minimum strength, skill, experience to cut the pressure branches. So by using this, we can this in, so by using this, we can easy the operator's job so that it will make the job become easier. So the duration of this project is SDG 19. So SDG 19 mentioned that to build resilient infrastructure, promote inclusive and sustainable industrialization and coastal innovation. So to relate this with our project, so we will build a machine that has better efficiency compared to conventional method. So this machine will produce better output or higher productivity of cutting the fresh branches. Also, we have smart connectivity either by using Wi-Fi or Bluetooth connection. And then we also want to reduce economic problems by introducing the control system. And the last one is cost saving. We will do a machine that has cost saving as possible as we can.
Okay, for the objective for our project, as what Dr. Sulaiman has before, we need to harvest FFB, fresh fruit bunches from the oil palm tree. The important one is with a minimum requirement of physical strength, skill, and experience, and the other objective is to identify the right fruit. Okay, so the scope of this project is one. Our system is only applicable to palm trees in tropical and subtropical regions, such as in Asia, Indonesia. We focus on Canara palm tree, which is Canara palm tree. And the second one is we harvest FFB, as what Haziq said before, at height of 4 to 6 meter. And the third one is we will use IoT to determine the right fresh fruit bunches. The fourth one, the the machine is suitable to be operated on moderate and even ground. We actually consider the ground of our country, but we don't want our farm or plantation, our machine to be operated in a very like not very uneven, like yeah, so difficult. Sorry guys. Yeah. So only on a moderate uneven ground. And the fifth one is we want to reduce the ergonomic problem faced by the farmers in Malaysia by designing a tool that requires like what the objective said before, minimum physical strength, skill and experience to cut right foot. And the last one is our machine will be semi-operated with human operated. Our problem statement is we want to design an automated harvesting system that intends to save time, one, and manpower, two, and also to reduce the economic effects of on the operator. That is our problem statement. Next design statement. For design statement, this design statement is actually our final design now, where we will design a tool that is the user's work to cut the FFP. Like I said, I'm using a semi-operated machine where the cutting. First, I will talk about the cutting system. Is by we chose to use a sickle attached to a vibrating motor. Why we choose to use a sickle? Because sickle, based on our research before, it is the best alternative to cut the FFP as it is easier to like move in the front of the palm tree, right? And then our cutting system will be connected to the lifting system, where this lifting system, which consists of the hydraulic system, and we will use the servo motor to do the 360 rotation of the hydraulic motor. And then besides that, operator can also identify the right FFP using Bluetooth camera with image recognition system. Next, for our collecting system, we will design a collecting system where the fallen FFP after it is being cut, it will fall first into our hook, hook with net, so that the velocity of the fallen FFP will be reduced. Then it will fall into the bucket below. And then for the driving system of our machine, we'll be using a deep groove wheels to counter the moderate uneven ground in our scope before. And lastly, for the system to be controlled easily, we'll create a control system which uses Arduino as a brand for our prototype and also use it. And this is our project methodology. The first one, we have already done it in the first 2 weeks, where we discussed about the needs, like HAZIQ mentioned it before, and then we define our problem. After that, we create a design. Each of us have created three designs, and then we did the screening for us to have the preliminary design. Then means one of our design is made it to the final before we choose our final design. And after each of us have the chosen from our three design, we redevelop it, and then we did the scoring matrix. Then we chose our final design, and we redevelop by we will be using platform.
Yes, you guys. Our background study is based on the petrol in Malaysia. The petrol in Malaysia is, as you know, is a non-renewable resource and will decrease in the future that will result to bad country economy. Despite that, Malaysia also has another resource that will benefit the country in the future, which is bulk oil plantation, which is believed by researchers that the oil palm fruit can replace the petroleum as a fuel in the future. The current technology for harvesting the palm oil fruit is traditional palm cutter. Not only that, according to a report from Malaysia's statistical department, There were approximately 400,000 laborers working in oil palm plantations on various field operations. Since those workers always use the traditional cycle to cut the fresh fruit bunches, which is the FFP, there is a disadvantage to using this method where the farmers were likely experience health issues such as skeletal muscle disorders. Farmers also frequently experience right shoulder and left wrist, also and right hand disruptors, leading them to believe that their work is being disrupted. Also, this disturbance is caused by the high pressure on the shoulder and wrists during the harvesting of an oil-bound fruit bunch. Besides the massive amount of empty fruit bunches produced as a result of the exponential rise in the worldwide palm oil output have created disposable issues in extensive forms. Since it is hard to collect the FFP without scattering, also difficult to cut it and identify the right fruits due to its height. Hence, it can be seen that this traditional technology requires a lot of workers. Also time consuming, not very common, and cause bad long-term effects to the workers. And the plantation also exists. In general, this innovation are needed to ease the farmer's life.
Okay, next I'm going to present the program design specification PDS. We have more than 20 PDS. I'm not going to touch every single of it. Okay, next. For example, the first one is the cost. We want it to be affordable. Our range is 5 to 10 feet. Design life is about 10 years. And energy is we are going to use electrical energy. For manufacturing, we are going to use CNC and 3D printing. Noise, to avoid hearing damage or focus, we assume it to be about 50 to 60 decibel. And the portability, able to maneuver. The prototype will be 1/10 of the actual size. Reliability, able to withstand high temperature, uneven surface and continuous operation. We are going to expect our machine to operate 8 hours per day. And the size of the actual machine will be height 2 meter, width 2 meter, and length 2 meter. And then the weight will be about 500 kilograms.
I will explain on how our group do the concept generation and concept selection. So first of all, this is our morphological chart. Here, since our group members are 6 members, so we need to do the 6 options here. We refer, it is based on the selected system, as you can see in the first column there, the referee system, guiding system, identifier code, quality system, driving system, and last but not least, the control system. Here we generate our ideas, we brainstorm our ideas to decide what kind of idea that we want to add to our machine. So from these ideas here, we can use the idea of each idea to make the conceptual design. So here each of us need to make 3 design. So here we can make an evaluation using the screening matrix. In this screening matrix, we make a plan in our group that I do the HAMRA one and HAMRA to evaluate my design. And here, from here we can improve what kind of lack in our design that we need to improve, and we will produce to the different design. As you can see here, we just only need to make just only one design on the design, and you can see here there is an additional feature here like a shelter house for economic factors, for safety factor. Then after we do the develop design, we can do the scoring metrics to evaluate our design. Here, to prevent any bias opinion, we just only discuss with those who do not the sketching. And after we evaluate them, we choose the design that has the highest score for the next final development. And here, how we evaluate it is on the what is given based on the first level is one plus 10 data, second was the data, three equal to data, four and the data, five was the data. That's all.
Okay, from the scoring matrix, we will have our ranking of the best design to the least usable design. So we will choose the best design and we move on for our final concept development. So once we have looked at our designs and the functions and also the needs of our project, we go back to our PTS and for the objective of our project. So we decided for our cutting system, we are going to use sickle for uninterrupted and efficient cutting. And we are going to use a vibrating motor to automate the cutting of the fresh fruit bunches. And for the lifting system, it's decided for the extension of the shaft and also the angle of it. We are going to use hydraulics. And for the rotation, we are going to use servo motor because it will provide better accuracy. And for the collection system, we have thought about using a basketball hoop design so that when the fresh fruit bunches drop, it can reduce the impact when it drops onto the basket of the machine so that there is no instability at the during the cutting process. And when the fresh fruit bunches are on the machine, we will release it to the ground for easier collection or to harvest more bees. So we are going to use a lowering plan for that. And finally, for our right and unripe fruit detection, we will use a Bluetooth camera which has image recognition algorithm so that it will identify ripe and unripe fruits and it will inform the operator. The operator will decide whether to cut or not cut. And then for control system, instead of the operator is going with the machine, we decided to go with a remote control operation and we were going to be designing an app which has an interface which can be controlled using a smartphone with Bluetooth connectivity. And the microcontroller that we are going to use for this system is Arduino or Raspberry Pi. So this is our final concept. After all the processes that we have gone through, finally we have decided this will be our final concept design. So let me explain one by one. So this will be our lifting system right here, and the rotation will be controlled by a servo motor. And we have the angle of lift here will be controlled by hydraulics, and also the extension will be controlled by hydraulics as well. So for the cutting, we will only use sickle. We believe sickle is the most efficient and is equal for the operator to operate and cut the special bunches. So we will be connected to a vibrating motor so that the cutting is a motorized cutter to ease the cutting of the fresh bunches. We will have the Bluetooth camera attached to the extended shaft then. So the Bluetooth camera will have a better view of the fresh bunches to identify whether it's ripe or unripe. And okay, for our collection system, this is the basketball design that we are going to go for. The fresh product drop here, we believe that the netting will absorb most of the impact and it will drop to our basket with the least amount of impact so that there is no instability for our system. And once it is filled, we will have like a releasing mechanism here. We will release the fresh bunches to this loading, by loading this line here. Okay, and for our driving system, so we will use on 4 wheels, big group wheels to tackle the uneven ground issues and to enhance the stability of our system. We also decided to use suspension. Okay, where there's a bracket here, we will attach our DC motor to this bracket, and then we will have a spring damper for the to absorb most of the unevenness to the ground. Okay, and our clearance, we decided the ground clearance should be around 1 meter for our system to work. And finally, for control system, this is the app interface that we are going to go for. This is a joystick like movement for the movement of the machine. And then we have the raising and lowering of the angle of the lifting system, and also the extension of the lifting system. And also we have the rotation control here. And this will be the indicator from the image recognition system to identify whether the fruit is ripe or not. So we will indicate here, and the operator will decide whether to cut or not to cut. Okay. And I think that's about it for our final concept. So in conclusion, the final design includes a remote controlling, lifting and cutting system that will allow chemical particles to be harvested without experience and physical stress. So the IoT-based image recognition system will allow for better recognition of right and unripe chemical particles. Hence, we allow for data collection to identify new information of harvesting operations. That's all from our group. Thank you very much.
Okay.